So this project is physics, centripetal force, and this time it's not PHET, it's a different applet here. It's called the Physics Avery, I believe. Yes, Physics Avery. So here we go, click on begin. This is about centripetal force. So apparently Isaac Newton is hanging on to this little pipe here, and then he rotates it, and there we go, and it's held down here by the weight of the washers, and that supplies the centripetal force, which then makes it rotate. One of the cool things is also you kind of can see that it's three-dimensional, right? Kind of, because the weight here, whatever ball or object there is on the string, is getting larger when it gets closer. They did make one mistake though. If you try to do that, that string that you have here will actually droop down due to its weight. It will actually, so it's going to be over your head but at an angle, not horizontal. Okay, anyway, I'm going to pause this one here and reset. There you go. So what I'd like you to do is max out the washers. This is a little bit arbitrary here though. Notice 31, 35, right, is the largest, but if I do that again, I get, well, 35, okay. There we go, that was actually 33. So you may not get the exact same number that I do have here, so perhaps 33. Max out the moving mass. That I believe is actually 250 grams, no matter how you do it. And then click this little piece of tape here. And there we go. That would be your first data point here. So it's very short. This will be very fast, I believe. Notice this is pretty much 25 centimeters. That's also a little bit arbitrary. You see the 100, 200 centimeters. So this one here is between the 20 and the 30. So it looks like almost exactly 25 centimeters. And then count the rotations until you get to 10.0 seconds. And so here we go. At some point I will actually pause to make it a little bit more accurate for myself. So here we go. And ready, set, go. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to just pause here. I'm going to try to hit the 10.0. Almost 11. Okay, it's more than 11. Okay, ooh, okay, I'll call it 10.5 because now it would be on the left. So what I'm going to do here is the table. Yep, oh, X7, Y7, I like that. So this here would be 25 centimeters long, and here I counted 10.5 rotations. The number of rotations is also an indication of how fast it moves. So this is kind of like the velocity, of course, would be number of rotations times the circumference. Okay, I'm going to go to, whoops, not this one here. I'm going to go to the next length, so I'm going to reset this one here. I'm going to click on this one here, which gets me, it kind of looks like, oh, I'm going to call it 42 centimeters right there. And yeah, same numbers of washers, same, the moving mass is the same, so don't change those. And here we go. Ready, set, go. 1, 2, 3, 4, 5, 6, 7, 8, and a little bit more, 8,5. Okay, almost 9. I'm gonna make it 8.9. Okay, notice, by the way, this only works if you count in German. So here I had, I believe that was 42, right? And this time around, this one's here 8.9. And then I'm going to add a plus sign here. Whoa, okay, it's a little bit too far in. There we go, it's a little better. And I'm going to make one more data point. And I keep clicking on the wrong thing here. There we go. So reset, make this again longer here, the little tape. And that's too close to what I had a moment ago, so I'm going to skip this one here. Might not happen to you, so that kind of looks like 59 centimeters, just short of the 60 or so, 59. So here we go. 1, 2, 3, 4, 5, 6, 7. Pretty much 7.5. It's on the left here. So what was it again? 59, right? And then I counted 7.5 rotations. Kind of looks like a straight line. Let me take one more. to show you that it's not a straight line. You might see a little bit of a curve here, right? Over and over again, I click on the wrong thing. So let's see, reset. And again, the yellow tape here. There we go. Kind of looks like just short of 75, so I call it 74. 1, 2, 3, 4, 5, 6. Okay, so 6.6 at this point, I guess. So I said there was 74, I believe I said that, 6.6. And here we can already kind of see that it seems to be a curve. So I will try a curve. Let's see. To the n power, and there we go. Looks okay so far. It looks a little bit off, right? But the more data you get on this one here, you will see that this hyperbola, which I put in right now, see the exponent negative 0.41 there, which means the negative means it's actually in the denominator, and that gives you this hyperbola. That the more data you get, the better this hyperbola will get. All right, that's it.